All right, let's go ahead and assemble our relay-based cascaded switching circuit that we'll be using in Studio this next week. So first we'll go ahead and assemble the circuit. We'll label the elements and features, and then we'll discuss the component values, and then finally some of the wiring details about the read relay. So let's go ahead and get started. Switching over to the online environment here. So let's start with a blank circuit. And what we're going to use first is let's go ahead and add some text labels here. First one, let's do here. And let's do, make sure you put in your name and your GU login. Okay, and we're going to use the 12-point font on this. And oh, right. Oops, delete on that one. Space bar helps me grab things. Okay, so we'll set that up here. Now let's go ahead and draw the circuit, and then we'll add the rest of the labels after that. So the one new thing we're going to get is going to be our read relay, and so the model for it is under passive components, add read relay, or excuse me, add relay. We'll change its characteristics here in a second. And so here it is. We'll come back to this in a few minutes, but it does have a coil for activating the relay and a switch that moves when the relay is activated. So let's go ahead and add some other stuff here. Let's add our voltage source. I did a right click, two terminal voltage source. We'll add that in here. Space bar, I want to size this up just a little bit here. We're going to need a switch, passive components, add a switch. And also add the current limiting resistor that we're going to need. Add resistor. And the default is 1000 ohms. We'll be correcting that in class. I'll probably make a modification here. Now add a wire to close this circuit. Again, this is the primary circuit. So we'll just close this. And you can see there is current flowing here, but coincidentally the switch isn't closing, isn't moving, and that's we'll take a look at the data sheet in a minute here about that. All right, so let's go ahead and finish this secondary circuit. We're going to need a second power supply. So right click, inputs and sources, two terminal, and we're going to feed voltage in. So the positive lead is going to go here, and once we'll add a wire here, and once the switch closes, voltage is going to go to two places, so we'll add a wire there and a wire here. Then we'll add an LED, because when this is turned on, we want to have it turn on, and then we're going to need to add another resistor here to limit the current on that. And then finally we'll add another resistor, and this will represent our loads. We'll put the labels on it here in just a second. And finally, we'll add the wiring to complete these two circuits. All right, so again, we've got our primary circuit and all its components. Let's go ahead and add the labels here. I'm going to select this, paste it. Let's label our important things here. So this is going to be our Uno, and we are going to use the 5-volt supply this week. So that's here. Oops. Control Z to undo that. Space bar allows me to grab and move things. Copy. Let's paste this over here. Again, this is going to be the secondary voltage source. Okay. And I'm going to add a few things here. So we'll add this label here, and oops, up here, and here. All right. Let's switch back, take a quick look at that circuit. So let's this voltage here, let's edit this. We've got, this is going to be R1. This one over here, resistor number 2. This voltage here is going to be the diode voltage VD. So up here, it's going to be the load voltage. And load resistance. All right, I'm going to switch screens and see if I missed anything here. Need VU and a couple of more things. All right, so let's make sure and add those labels here. So, and again, this side over here is our primary circuit. And this side is a secondary circuit. Add this is going to be our on LED. This is going to indicate when things are operating properly. Some of our and that's for the real world piece, but we're modeling it here as well. All right, I'm going to add a couple of more items here. C, E, E. All right. It's going to be these are pin labels. We'll position them here in just a second, but we'll start by labeling, creating them. These are just labels for the pins because it ends up being important as we're working on this. And then finally pin 7 here. 1, 3, 5, and 7 are going to be the pins on this relay. And so I'm going to go ahead and place them right now. All right, so let's switch back and see if I missed anything. Yeah, a couple of plus signs, just to leave some clarity on the circuits here. Let's add I'm going to size this up a little bit. Alrighty then, so that gets our circuit labeled. Again, we've got the primary circuit with the power supply going through the current limiting resistor and the relay, the coil. I forgot to label this one. This is going to be the resistance of the coil. Alright, coil resistance should be all set. And so that's our primary circuit. The secondary circuit goes from the power supply through the switch when it's closed, turns on the LED. But it also turns on the load, so the voltage is being applied to these parallel items. One of them is a series connection of the diode and the current limiting resistor for the diode. All right, so let's edit a few properties here. So again, we'll double click the power supply, and since we are using the UNO 5 volts this week, that one's okay. Let's go to the secondary power supply. We'll have a few different ones, but we'll use the largest one in this example, 12 volts. And LED, the resistance loads are going to vary, but you'll be fixing these. They're going to be less than 100 ohms, but we'll put in 100 for now. And then choosing this current limiting resistor, 1K might be close enough. We'll leave it for now. But the last thing we want to edit properties on is the relay. So let's open this up. And it has a handful of properties here that we can adjust. Let's take a look at the data sheet. I'm going to switch over to the data sheet for a second. So looking at this is our small read relay. It is important that when you're wiring it, you keep the labeling in mind. You can see that through this layout section 1, 3, 5, and 7, that's the same numbers I added to the previous drawing. And so from left to right, it will be pin 1, pin 3, pin 5, and pin 7. That's because on the breadboard there are other pins in between, other opportunities to have connections in between, but not on this device. So let's take a look at the coil data and information. Switching back to our relay. So we need to find the inductance of the coil. Let's take a look at that. Coil inductance right here. It's about the 6th one down. Coil inductance 100 millihenries. This one says it's 2, so we'll make it 100. Let's look at the on resistance. Contact data, that'd be on this piece. So contact resistance static, that meaning on. So it's 100 milliohms right over here, 100 milliohms. So it says 50. We'll make that 100. Off resistance. So insulation resistance is the one that they're talking about here, and this one's huge. It's 5 teraohms. So I don't think we need to worry about making it 5 teraohms, but let's increase the size of it a little bit. It says 1 megohm. Let's make it 100 for now. Okay, and then the on current. Let's take a look at that piece. So the current right here, on current, is supposed to be 6 amps is what it needs to operate. But you'll notice the pull-in voltage is 2.1 and the activation voltage is 3. So actually we should be able to choose the ratio of this. At 2.1 volts we're going to get about 2/3 of this current. So that means a turn on voltage of about 4 milliamps. Turn on current of about 4 milliamps should work. And so let's take a look at, let's add that. 4 milliamps. It is a 1-pole switch. And then the coil resistance, let's take a look at that. Coil resistance, our very first item here, typical is 500, and there's min and max ranges in the fabrication. So we'll use the typical value. Okay, so that 500. And okay, so now that switch, you can see it's partially open now, not quite working. And so just to show the current flow here, I'm going to cut the resistance here maybe to 600 just to get us started. And so that gets it closed. And again, the open and close feature allows it to start working. All right, so let's take a quick look. You notice I labeled the relay pins 1, 3, 5, 7. So looking at pins 3 and 5, they represent the coil. And it is important, I'm going to switch to the data sheet for a second here, go back to it. It is important that it has inside, it has this small diode connected to it. So it's important to have the coil, the positive terminal coming in here on pin 3. And so let's switch back to our image. So we've got the positive terminal going through the switch, through the current limiting resistor, and then reaching pin 3, while number 5 is closest to the ground or negative side. So again, that's how we want to do the wiring for that piece. Let's take a look at the other pins. Pins 1 and 7, or in this case, the far left and the far right when you're facing the label. And that will be important to make sure the label's facing you as we take these, make these observations. Current will pass in on pin 1 through the switch and then out on pin 7. And so let's take a quick look at that. We've got our voltage on the secondary voltage providing power to pin 1. The switch closes, it goes through pin 7, and then gets connected to the LED circuit and the load circuit, which will be, oh, we are missing one label. Let's add one new label. And again, our loads this week are going to be a bulb or lamp, a fan, and a valve. So that, we're going to have 3 different loads. All right, so that's the end of our circuit. So if you've got this set, you'll be able to play around with this in class and also use it to model what you're actually going to do in class. So let's go ahead and save this. File, save the link as, and it'll save it with a known name to your downloads area again, and then you can go rename it appropriately and do it as part of your submission. That brings us to the end. We'll look forward to seeing you in studio.